Okay, so at this stage we have just found A, B, C, D, E and F in plan and elevation, and we've drawn the intersecting planes A, B, C and A, B, E, F. Okay, so that was part A of the question. Part B of the question is getting to the dihedral angle, and as we saw yesterday, there are kind of four main steps in order to do it. For the dihedral angle, you need to find the line of intersection and get the true length of this line. So, with the question in mind, you have the surfaces A, B, C, D and A, B, E, F. AB is obviously the line of intersection between them, and I'm just going to show you this in colour, and I'll get the true length of it then. When you take an auxiliary, the first thing you draw is an XY line, and you can do that XY line up in this direction, up that way, or down this way. If I go up to the left-hand side, I have very little space on my page because I have kind of kept it close to the left-hand side of the page, so I only really have space down in this direction, so I'm going to do the auxiliary down to the right-hand side. Your line of intersection is AB. You don't need to do it in colour, I'm just going to highlight it, LOI. So that's the line of intersection. I'm now going to get the true length of the line of intersection by drawing an auxiliary away from the object, so you can see I haven't touched it. The first thing I'm going to draw is an XY line. And I'm going to label this XY line X1, Y1, and you can see this is heavy, and you can draw it heavy if you like. I'm going to bring out B, and I'm going to bring out A. Now, when you do an auxiliary, you always have to measure from your last XY line back. So this is my new XY line, my last XY line was there, and back is this direction. So I'm going to be measuring heights. Now, A, I can see is on the ground, so A will be on the ground here. And B is up that 60 millimeters, but I can just measure it with my compass and transfer it. Okay, so measure from the ground up, and then obviously measure from the ground back. Now that you have A and B, join them together, and this is the true length of your line of intersection. And we'll go back to the steps in order to see what else we need to do. So those 4 steps, you need to learn these. You're never going to be told these are the 4 steps in doing a dihedral angle, you just need to learn them now. So the next one is I obviously need to get 2 other points, one from each surface, by looking along the true length of the line. So I'm going to look along the true length of the line. I'm usually meant to bring out 2 other points, but I'll do that in a second. So look along the true length of the line, and we're going to see this as a point. So the first thing you're going to do is draw your XY line, and because this is the third one, I'm going to call it X2, Y2. And again, with an auxiliary, you always measure from your last XY line back. So this is my new one, that's my last one, I'm going to measure back to it. So the distance to AB is consistent, it's the same. So I'm going to take this distance, and for my new XY line, I'm going to strike it off. So AB is in the centre there. And I'm just going to reflect back on what needs to be done. So I found the true length of the line of intersection. That was my first auxiliary. So I'm just going to write that down. Auxiliary 1. Then I've looked along the true length of the line of intersection to see it as a point. That's auxiliary 2. Then I need to bring out 2 points into this view. So bring 2 points out into the second auxiliary, one from each surface, and then measure the angle. So this is one surface and this is the other surface. I need to bring out 1 point from surface A, B, C, D. I need to bring 1 point out from A, B, E, F. Now, it doesn't matter if I choose E or F from this surface, or C or D from this surface. I just need 1 from each. And the easiest ones are the ones that are actually already on the ground. Now, you can see here D is on the ground and F is on the ground. So D and F, when you bring them out, they're actually on the same line. What I mean by that is when I start bringing out A, B and so on, and I bring out DE, you can see they're in line with each other. And that means they're both on the ground at the same point, D and F together. So then when I bring them out into my second auxiliary, what I'm looking along the line AB, so just make sure you're going parallel, bring D and F out together at the same time. And I'm going to find D and F on this line. And I know that you can't really see that, so I'm going to just push it up a little bit more. Okay. Again, to find D and F, I need to measure from my last XY line back. So this is my last XY line and back is this direction. So D is really close. And because it's really close, I won't be able to measure it very accurately with my compass. I am going to use my ruler for this because my measurement here is 2 millimeters, which I wouldn't have been able to measure with my compass. So there's D. And F I can measure with my compass, so I'm just going to grab it. Measure back the distance from your X1, Y1 to F. And then strike it from your F2, Y2, X2, Y2. So I have D and F and A and B. And because with your line of intersection, if you look along that line of intersection, you're going to see the angle. So AB is the center of that angle. So all you're going to do is join D to A and B and F to A and B, and you'll have the angle. And like you've seen before, you need to show the dihedral angle by doing 2 little triangular wedges to the center, putting a dot in the center, and you measure the angle. Now the angle is not really sure, I think it's around 70 degrees, but it's 65 degrees, apologies. And 65 degrees exactly. And depending on your accuracy, you could have anything up to 70 degrees or down to 60 degrees. So anything between 60 and 70 is perfect, but 65 is the actual angle. Okay, that is part B of the question. Okay, so again, just a reminder, you need to learn those 4 steps in order to find the dihedral angle. It's the same thing every time that you're doing, so you just need to get used to doing it. This is the true length of AB. I'm just going to write that in. Okay. Part C of the question is quite tricky, and I'll go through it with you. So determine the true shape of the surface ABCD, and on the true shape include a diameter circle of 20 millimeters for the poured hole. Given that the center is 30 millimeters away from the line AB and is 50 millimeters from the point D. Okay. So in order to draw a true shape, you need the true length of every side. So I'm just going to focus on this shape, and I don't really need to colour it in, but I will colour it in just to highlight it to you. Okay. At the moment, we need to figure out which lengths we have the true length of and which ones we don't. So I have AB, so I'm just going to give a little tick to it. Now you don't need to, you can obviously see it there. There is another line that we have the true length of. A and D are on the ground. So when you look down on top of it, you can see its true length as well. So this is also a true length. So pretty much with all the true length lines, I'm just going to put them in orange so you can see them. So that is a true length as well. Okay. Now, I do not have the true length of CD because C is up high and D is down low, and it's at an angle, and it's at an angle in plan, so I'm not looking at its true length. The same can be said for AB, or for CD, again, because we're just not looking at it correctly. So in order for me to be able to do the true shape on this page somewhere, I need to first of all have the 4 true lengths. So I'm going to work on that. To get a true length, like we did here, we need to take an auxiliary. So I have 2 more auxiliaries to take to get the true length of these shapes. And again, just double checking that you can see everything there. Now, I am going to do an auxiliary just out here to the left hand side for CB is what I'm getting the true length of. So randomly, I'm doing an X3, Y3. I'm bringing out B into it, and I'm bringing out C into it. Okay, and all I need to do in that is measure the height of C and measure the height of B. You're going to use your compass for this. So B is the height of 60, so measure the height. I know people are probably kind of getting confused. I thought you have to work from your last XY line back, and I'm going to explain that again to you, that I am working back from the last XY line. I'm just joining those 2 points together now, and I'm going to do it in orange because again it's another true length. Okay, so I've just taken another auxiliary perpendicular to CB. I've measured the height of C and the height of B on it, and I've got its true length as well. So earlier on we were looking at auxiliaries, and we always work from our last XY line back. So the first XY line was the ground, and we drew our elevation and we drew our plan. You always work from an elevation to a plan or a plan to an elevation. Grand. With that in mind, the first auxiliary we did was to get the true length of this line. We were working from the plan, which came from the elevation. So that's why we measured the heights here in this view. We are now working from the plan for CB, and we came perpendicular. That plan came from this elevation, so again we're measuring heights. Back here for the X2, Y2, we looked along this view. This was an elevation, and we're now getting a plan view. This came from here, and this came from that view, so I have to work back to that. Okay, so you can see it's every second one I'm working towards, and that's why I was working as a height in that second auxiliary. Okay, now, so I have 3 through lengths. I need to get the fourth through length. And all I'm going to do is, again, CD is the last side I need. So working parallel again. Draw an XY line parallel and take your 2 points out perpendicular. And I think my set square slipped on me for a second. Now, D is on the ground, as we know, because you can see it there. This is from the plan working into an auxiliary, so I have to take it the heights from this elevation. And C is up a measurement of 20. Just take the 20 on your compass and strike it off. And now I finally have the true length of all 4 sides. Okay. So I have 1, 2, 3, 4. Now that I have all 4 lengths, I'm still not out of the water, simply because in order to draw a 4-sided figure, and I'm just going to sketch this on a piece of paper. Okay. I have 4 true lengths now. And let's say I take the biggest one and I draw it first. And let's say I get my compass and I take this distance and I strike it off from this corner. And let's say I take this distance and strike it off from this corner. I have no idea where this last line goes because it could go in a multiple different range of views. So in order to draw a 4-sided figure, what you do know how to do is, if you had 3 lengths, you put the biggest one on the bottom, you take the next smallest side and you'd strike an arc, and then you take the last side, sorry, I'm going to make that a little bit bigger, and you strike an arc, and you get your triangular shape. Well, now we have a 4-sided figure. And as I was explaining to you, you can't draw that shape without knowing the angles. But what you can do is you can create a triangle on the shape. It's like crossing the diagonal on the shape. Either one of it, doesn't matter which one you do. But if you have a 3-sided figure, you can draw that shape no problem. But when you have a 4-sided figure, you don't know what to do. So when you have to draw the true shape of a 4-sided figure, yes, you need all the true lengths. So we've got the 4 true lengths now. We've got 1, 2, 3, 4 true lengths. But because this surface is 4-sided, you can't just go off and draw it because you don't know what the true angles are of any of them. So what we're going to do is introduce a diagonal and get the true length of the diagonal, and then we can solve it. So the learning of this question is when you have a four-sided figure, you need to create a triangle in the four-sided figure and then get the true length of the diagonal in it. And then you can create your shape. So this is tricky, in a tricky principle to get across, but for a four-sided figure, you need to create it into triangles. Any odd shape that you're asked to get the true shape of, create triangles on the surface, and then you'll be able to get it no problem. So I'm after drawing a diagonal on this surface from A to C. I could have done D to B if I wanted to, but I chose A to C. This is not a true length, so I need to get the true length of that line first. So what are we on now? This is my fifth auxiliary. So come off perpendicular to that, so we're going to draw a new XY line anywhere. We're going to bring out A into the drawing and we're going to bring out C into the drawing. And I'm going to measure the heights of both. So A is on the ground and C is up a distance of 20. And I'm going to join those two together. And that's the diagonal true length. Now I have everything I need in order to start drawing this. So I have A to B, I have B to C, C to D, D back to A, and then I have A to C joined in, drawn as well. Anywhere on your page, I'm going to use this line as my starting line and I'm going to pick a point to start. Doesn't matter. And I'm going to call that point A. So I can draw A to B or I can draw A to D. I have all the true lengths here. I'm going to choose A to D. Take the true length of A to D on your compass like I'm doing here now and strike it off. Okay, so I've that done. You can see I'm going to do A to C now and then I'm going to do D to C. So A to C is this red line that I've just got the true length of. So A to C, strike it off. It's going to be over there somewhere. And then D to C I have here. So take its distance, the true length of it, and strike it off. And you can join that in. So I've found C now is what I've found. So A to C was the red line, so I'm going to draw that red line in. D to C can be drawn in also. And now I can work on the other triangle, which is ABBC. So I'm going to take AB on my compass, which was this original line that we found. From your compass, strike it off. Okay, so B is going to be on that arc somewhere. I'm just going to turn down the light a little bit just because it is a little bit glaring. Maybe you need it. Okay, that's better. Okay, next I'm going to take the distance from C to B. So C to B is this distance. So I'm going to strike it off. Take its distance on your compass. And from C, strike it off. Okay, and where the two arcs cross over, that has to be my last point, which is B. Join your shape together now, so we have it, thankfully. So from doing graphics since first year, you have learned how to draw triangles, and we are just using the notion that you're able to draw a triangle to draw a true shape. So if you have a shape that's bigger than a triangle that has more than 3 sides, introduce triangles into the shape and then you can get the true shape of anything. So if you get the true lengths of all of the sides, then get the true lengths of the diagonals in it, you can finish the shape. But that isn't part C finished yet. So it says determine the true shape. We've that done. It took a while, but we've it done. On the true shape, include a diameter circle of 20 for the porthole, given that the centre is 30 millimeters away from AB and is 50 millimeters away from the point D. So this is my line AB, and I need to figure out where a point is 30 millimeters away from that. Okay, so I need to measure 30. I'm sorry, I'm going to use a better set square than that. I'm just going to slide my set square parallel to the line AB because that will be a consistent distance 30 millimeters away. So on this line somewhere is my center point, but I also know it needs to be 50 millimeters away from D. So on your compass, measure 50. Okay, so measuring the 50, and from D, strike it off. Okay, so that's the center of the circle. What needs to happen now is I need to do a diameter of 20, which is a radius of 10. You can measure the 10 on your compass, so you can draw that circle in with that being your center point. But I have a little trick up my sleeve, and this trick is my circle holder. So just going to line it up. Okay, and that's it. Okay, so you will just measure 10 on your compass and you'll draw that circle in. I just have a circle template for any circles that are quite small. Okay, so that is part C of the question done. The dihedral angle was part B of the question. There is one more part left, and this is the oblique plane that we've been looking for. So I'm just going to bring that into the focus now, and I'm going to move this light off it a little bit. Okay, so for part D of the question, you're told the midpoints of the line AB, AD, AF define the oblique plane. So you can see here, there's the middle of the line AD, the middle of the line AF, and the middle of the line AB define a plane. You can see the plane there, and the plane is up 5 millimeters in elevation. You were asked to draw the elevation and plan of the seat, and then determine the VTH, the vertical and horizontal traces of that oblique plane. So let's get started. I need to get the middle of this line, and this line. So we're going back to basics, back to drawing that we would have done in junior cert, line bisection. So compass at F more than halfway, strike an arc. Same from A. Repeat on the far side. Join the lines in. Okay, when you have the 3 points in plan like I have, you can join them together. So we're going to join all of those corners together. Okay, so there's the plane found, but I'm going to draw it up in elevation, and then I'm going to put it in heavy in plan because I can't put it in heavy in plan just yet. Okay. So just transfer the points up like you normally would any other point. So this is on the line AB, so transfer that point onto the line AB. This is on the line AD, so find it on the line AD. And finally, this is on the line, what is it? AF. And we need to measure 5 millimeters up to see where that plane is. Join A to each of, join the midpoints together, all of them. And you can see where that plane actually is. And I'm going to colour it in. So there's the oblique plane in. So it's 5 millimeters up off the ground, and it's joining the 3 midpoints together. Now I'm transferring down the endpoints of that plane down onto the correct lines. And that'll get me my plane in plan, which I'm going to colour in slightly heavier. Okay, so now that we have the plane, we're asked to now get the traces of that plane. As I've explained to you before about the oblique plane, the plane touches on the ground. You need to find 2 points on the ground. If the plane isn't on the ground, you have to force points to touch the ground. So see here, this plane isn't actually touching the ground, but that line is continued. We've got a point on the ground. We have the same point in plan on the ground. So we actually already have 2 points on the ground. If we join those together, we'll get the line. And I'm going to do this in heavy. And you should be doing it in heavy as well. So the plane is a heavy line. So this is your HT. Okay, that's your horizontal trace. To find your vertical trace, you're always best to take the highest point, which is this one here, and come parallel to it and find it in elevation. And that's exactly what I'm going to do now. So we're going to slide our set squares parallel to HT, going through that top point of the plane, see where it touches on the ground, and bring it up vertically. And then transfer that point across. So I've brought this point parallel. I've brought it up. Normally what you do is you bring it to the VT and then bring it across into position. But now that we have it in place, we'll work backwards and bring it across to the height line that we have. That has to be a point on the vertical trace, so you can join it in also. This is our VTH found. This question had a lot in it, okay, and that was part D of the question finished. There was an awful amount in it. Between getting a true shape of a four-sided figure that isn't a regular shape, you need to involve triangulation. We looked at the hedral angle for the second time, and obviously we practiced auxiliaries a lot here. There was 5 different auxiliaries used in this question, and then we also had the VTH, the oblique plane, in it. It's a really good revision question because it shows you so much to do with this topic. Not only just the hedral angle, but also VTHs, but also true shapes and just basic drawing skills. There was a lot of auxiliaries in it, and it's a good one to practice the auxiliaries because it comes up every year, at least twice. So let me know how you get on.